Distinguished guests, ladies and gentlemen, welcome to the distinguished lectures organized by the Hong Kong Institution of Engineers. I am Cindy Zhang, the member of HAIE President Protégé Scheme. This afternoon, we are honored to have Mr. Shan Qiming, Director of the Hong Kong Observatory of the Government of Hong Kong SAR, to be our guest speaker today. Now, may I now invite our President, Engineer Thomas Chen, to give us the welcome speech. Engineer Chen, please.
Mr. Sun, distinguished guests, fellow members, ladies and gentlemen, good afternoon. On behalf of the institution, it is my pleasure to welcome all of you to the first distinguished lectures of this session. The theme of the lectures this year is climate change and engineering solutions. We are increasingly aware of the threat of climate change. That is one of the shared challenges faced by everyone, everywhere. As the institution is the only professional body representing all the engineering disciplines in Hong Kong, social responsibility is one of the institution's priorities. In the face of the challenges posed by climate change, the institution shares responsibility for creating the platform to link engineers, scientists, and academicians to exchange their wisdom, knowledge, professional expertise on the topic. This year, we are truly delighted to have invited two prominent speakers, Mr. Sun Qiming and Professor Robert Rosenstein, to share with us their insight into the topics related to climate change and slope stability, respectively, in the two distinguished lectures. Let me start by introducing our distinguished speaker today. Mr. Sun Qiming is the Director of Hong Kong Observatory of the Government of HKSAR. He is a renowned expert in aeronautical meteorology. He is also the first Asian taking up international responsibility in serving as the President of the Commission for Aeronautical Meteorology of the United Nations World Meteorological Organization. He led a team of researchers to develop the world's first and award-winning light detection and ranging wind shear alarming system for the Hong Kong International Airport. His other professional affiliations include Chair of the Hong Kong Meteorological Society, Fellow of the Royal Meteorological Society, member of Chinese Meteorological Society Executive Committee and Government Steering Committee on Climate Change and Radiation Board. Today, Mr. Sun will deliver a presentation entitled Global Climate Change and its Implications to Hong Kong. In his presentation, he will review the latest situation of climate change and highlight its implications to Hong Kong. I firmly believe that you will find today's lecture rewarding and inspiring. Before I close, I would like to take this opportunity to thank Mr. Sun Qiming. I would also like to extend my deep appreciation to members of the organizing committee, our sponsors, and all the participants who make the lecture possible. Thank you very much.
Thank you, Engineer Chen, and please stay. Now we will move to the souvenir presentation ceremony. May I now invite Mr. Shan, our honorable guest today, to come on stage and receive the souvenir. Mr. Shan, please. Thank you, Engineer Chen and Mr. Shan. Please stay. May I now invite all the members of the organizing committee for the distinguished lecture, the HKAE past presidents, as well as the representatives from our sponsors, including Arab, Junwo Development Holdings Limited, Construction Industry Council, Philco Hong Kong Group, Henderson Land Group, Hopewell Holdings Limited, the Hong Kong and China Gas Company Limited, to come on stage and take a group photo. Thank you, and please be seated. May I now invite our speaker, Mr. Shan, to deliver his presentation on global climate change and its implication to Hong Kong. Mr. Shan, please.
Testing. Okay. So, good afternoon. Thank you so much to the Hong Kong Institute of Engineers for me to talk to you today. It's indeed my privilege. So, I think all of you understand climate change to a certain extent, but I think it may be a good idea to just refresh where we are actually. In fact, the carbon dioxide level has been rising, I think, as you all know, but has reached almost, we could say, unprecedented level, beyond 400 ppm the past few years. And this year is already 403. Actually, it was the average last year. But if we look further backward, we found that we have not been at this high level in the past 3 million years. So if we look at what happened 3 million years ago, the temperature was 2 to 3 degrees higher than now. And the mean sea level was even higher, 10 to 20 meters higher. So, of course, you all know that the sea level projection by the IPCC is not yet that alarming. But this is what the history is telling us. Of course, the temperature. I think you might have heard from the news that certain time when the winter was a bit cold, the snow was a bit heavy, then people would say, oh, we have a 1,000-year cold winter, or even saying that the global warming has stopped. But if you look at this chart, you cannot see the global warming being stopped. In fact, we have been having the hottest years in the past 2-3 years. And I think you all heard about the so-called hockey stick, and this is the shape of the temperature, which resembles a hockey stick. And this is what happened in the past 3 years. And this year, I think we are targeting to be on the third hottest year on record. But of course, last year, if you remember, we had the hottest year globally. And maybe some of you still a little bit doubtful about whether the warm weather, whether or not it is really a man-made effect. If you look at the, actually you can see this was the temperature, global temperature in the past 10,000 years. And you can see that actually the natural variation actually happened quite smoothly. And this was related to astronomical, the movement of the Earth. But you can see that the slowly decreasing trend was opposite. Now the trend is sharp, abrupt increase. And so it is difficult to imagine how the nature has changed so abruptly. So mankind is the culprit. So now this year we have seen a lot of extreme weather and a lot of climate change effects. But I want to focus on first one thing is the melting of the ice. This is really a concern, I think, to me, starting last year. You can see that in the Arctic, in the Antarctic, and actually as a whole, both together, you can see that we have been hitting almost the lowest mark. And it's particular in the Antarctica. I think we still don't know quite sure why it's dropping so rapidly in the past year. And it's still at a very low level. You can see that we have never reached such a low level in the Antarctica. And so you can have many such comparison of glaciers. And in fact, personally, I have been to a glacier in France, Chamonix. And I found that after 20 years, I have to walk, I think, more than 150 steps down to reach the surface of the glacier. So you can imagine how much ice has been melted in 20 years. And you can already see some glacier disappearing. So, and the loss of ice in the Antarctica, in Greenland, has been tremendous. I think we cannot imagine how much this represents, how much loss this represents. We're talking about gigatons of ice being lost every year. But one video, I think, I don't have enough time to show you here, but you can easily Google it and find this chasing ice video on YouTube. You can take a look. It's some passionate photographer trying to capture how glacier changes over Greenland and other parts of the world. And they put a camera, and then they do regular maintenance. And then somehow, this guy captured the, I think, largest caving of a glacier in Greenland. And you can see that the size of the glacier, all the ice, having several hundred feet toppling in front of you just in a matter of 1 hour, 75 minutes. And the size was actually tremendous. In the movie, you can see the comparison of the area of the caving of the glacier to be at the same size of lower Manhattan. So I compared it with Kowloon. It's similar in size. So you can imagine, in 75 minutes, the whole Kowloon toppled. All the buildings toppled. But in this case, the ice actually was even taller. than the buildings of Manhattan, 2 to 3 times higher. So you can see the dimension, the scale. So you cannot imagine how many gigatons, but you can see it before your eyes. And of course, the result is sea level rise. And so you can see that in the past 100 years, you can see the increasing trend of the sea level. And the problem is that the rate of increase is higher and higher. Of course, it's still a small number in terms of millimeters per year. But adding up in the matter of decades, we'll see a meter increase in the next 100 years. So to me, this is, I think, a challenge for Hong Kong, being in a coastal area. And of course, not many good news, but all bad news. I think if you look at the newspaper, you can see some discussion about a point of no return on the melting of glaciers over the Antarctica, Amundsen Sea. And they're talking about, in the past, some physical setup. I think your engineers, especially the geotechnical engineer, will understand that the seabed has been preventing the glaciers from sliding into the sea. But now we have already passed the point of no return, as the warm seawater has eroded the ice sheets from below, and so further and further. And so this seabed structure can no longer stop the glacier from melting and from sliding into the sea. And so if everything evolve as planned or as forecast, then we will see at least a meter increase of the global sea level just because of this. So, so this is beyond what the IPCC is projecting. We are expecting 1 meter increase in the next 100 years, but without taking account of this. So if this happens, we don't know when, 100 years, 200 years, we don't know. But if it happens even quicker, then we have to upgrade our projection of the sea level rise. So I think we will see more and more such bad news. And so, every time the scientists update the assessment on climate change, you will see the sea level rise to be adjusted upwards. So this is still the trend. Now, for Hong Kong, I think all of you, before August this year, you only hear me, the director of the observatory, always saying that please be concerned about sea level rise and storm surge. But then maybe you have forgotten about storm surge, because the last one, very significant one, was already 1962, Typhoon Wanda, where I haven't yet born. So, but what is storm surge? Actually, you know, a typhoon, a cyclone, the winds are rotating anti-clockwise. And so if the cyclone happens to be south of Hong Kong or west of Hong Kong, then you will have the wind direction pointing towards the land, so pushing the seawater towards the land. So this will lead to an increase of the sea level along the coast. Another factor, of course, is the low pressure sucking up the sea level. And so these two factors together, plus one other factor, is the tide, the astronomical tide. If this storm surge happened at the same time as the high tide, then we will see what happened in Macau. But if it happened just opposite during the low tide, then nothing serious. Again, something like a few years ago, I think you remember the typhoon Usagi, Tin Tou, and everybody complained about the observatory making or alarming message that it could be very devastating, but in fact, Usagi landed to the east of Hong Kong. And so we haven't been exposed to the onshore winds, and therefore, not much storm surge. But this time, Hato, we actually witnessed the effect. Now, of course, if you remember New York, New Jersey, they experienced Hurricane Sandy in 2012. And you can see the underground being flooded. And again, Haiyan, 2013 in Philippines. More than 6,000 people were killed mainly by the storm surge. If we look at the history, actually the same place, Tacloban, was impacted by a similar typhoon, similar storm surge 100 years ago. Not just once, but twice. Also killing 6,000 to more than 10,000 people. So we have to learn from history. Now, of course, climate change, global warming, you expect that we will have less and less cold days, more and more warm days, hot days. And this is in fact happening everywhere around the world. And so you will expect more and more such extreme events like heat wave. In India, for example, in 2015, more than 3,000 people died. Always the conclusion is that this would not have happened or would not be so extreme without climate change. Of course, in France, it was really, I think, the first wake-up call for Europe that a heat wave could kill so many people. And also the scientists concluded that it would not have happened without climate change. The chance of this happening is only 1 in 1,000 years, but the climate change has actually decreased the return period a lot. So, of course, a warming atmosphere would also mean that the sea surface will be warmer, and so more water vapor will get evaporated from the sea. And also the atmosphere can hold more water vapor, and so, which means the water cycle will be more intense. And so where you have rain, you have more rain. Where you have drought, you still have drought. And the climate is shifting to actually more heavy precipitation, but less light precipitation, or in other angle, less rainy days. This is what we are expecting. But unfortunately, again, more extreme events. So this is also happening everywhere. For example, in the US, they see more and more, the return period to be decreasing, and also the magnitude of the rainfall is increasing. Now, Paris Agreement. Of course, a lot of people rejoice, so problem solved. But actually, it's not. Of course, I don't want to mention Trump today. But still, if you look at, the target is to cap the temperature increase to within 2 degrees from the pre-industrial level. But in fact, it has to be very, very ambitious reduction of the greenhouse gas if we ever want to reach the 2 degrees scenario. Actually, we don't think it will happen. It is not realistic. Now, the nation's pledges for CO2 reduction will put our carbon dioxide level to this level by 2030, which is only midway to the 2 degree target, midway. And so, we have yet to see whether or not we will still follow this higher rate of change, or to start to have a reduction after reaching a peak around 2030. I think China has a national policy to achieve the maximum. Earlier, the better. But if we don't comply with the pledges, then we will still be increasing. This is the business as usual trend. So this year, we are already 1.1 above the pre-industrial level. And so we are already on the other side, towards 2 degrees. So given the pledges, actually, we're expecting that by the end of the century, we will still have 3 degrees increase. That means we have to try harder to mitigate, but at the same time, we need to think about how we could adapt to climate change. So sea level will rise, the temperature will increase, so we have to adapt. So for Hong Kong, of course, I think this is very simple physics or common sense to expect that we will be hotter, getting hotter and hotter. Sea level will continue to increase, less cold days, and the rain will get heavier. So for us, this is already a trend, the temperature increase at the observatory. Of course, this is partly due to the climate change and partly due to the urbanization. For example, today you can feel a little bit of cold around Hong Kong, but at the observatory or in Central, you have 1 or 2 degrees higher than the neighbors. So this is the urbanization effect. You can expect to have tremendous increase in the number of very hot days. This is the business as usual scenario. You can see really large, a very large increase in both the very hot days, 6 times, and even the most, I think, impact on Hong Kong is the hot nights. This year, we have 41 nights with hot nights, which means the minimum temperature was at 28 degrees or higher. So people tend to use their air conditioner. I haven't. Now, this is the really a trend, you see. And we have just broken the record. And also to start to have hot nights even in October. And the rain, of course, again, the engineering departments will now be very familiar with this chart, which we can see that the increase of the record, of the hourly rainfall record, is becoming faster and faster and higher. So I'm not able to forecast what will be the next record. It is really difficult to forecast the extreme. But you can see that the return period of the heavy rain is getting shorter and shorter for all the different time scales. So a lot of work for you engineers in the years to come. Sea level rise. Again, this is a steady increase. And so if we look at the different scenarios, for example, we compare this 4-degree world versus the 2-degree world. You can see that even for a 2-degree world, the number of hot nights, very hot days will still increase. So even if we reach the target, we still have to adapt. But if we cannot reach the target, for example, in the 4-degree world, you can see up to 10 times of very hot days by the end of the century. Hot nights 7 times. And almost no winter. Almost. But maybe you can still occasionally get a 12 degrees. But and also for the precipitation, you can expect to have a somewhat heavier rain, more extreme wet years, but still you will have still some dry years. If you remember 63, the year when I was born, so the drought could still return. And sea level rise. As I mentioned, by the end of the century, you expect 1 meter increase. But of course, it also depends on what happened over West Antarctica. If the West Antarctica collapse, the glaciers collapse faster, then it's not just 1 meter. This is, I think, as expected, hot days, hot nights, and little cold days. And we also try to do the comfort. If Hong Kong in the summer it could be very, very warm and also very humid. And so we also project this scenario, warm and humid. And you can see that also a large increase of such warm and humid days. So this will affect the comfort level of people on the street and also, I think, the workers, construction workers. And of course, more extreme rainfall, but at the same time, the chance of drought still there. And the rainfall intensity will increase. The number of days, however, will decrease, which means, as I've mentioned several times, whenever either it doesn't rain, but if it does rain, it will be heavier. And of course, landslip, I think we all remember this just around here, you know. Yeah, this is Kok War Road, 1972. And of course, GEO has done a lot to improve, and so we are basically safe today with man-made slopes. But of course, the event of 2008 also reminds us that the natural slope will be another issue. And this I borrow from GEO. I am no expert in geotechnical engineering, but I think we are all concerned about the heavier or extreme rainfall bringing instability to natural slope. And the crossover point, as I was told, is around 20%, 24-hour rainfall of the year's rainfall. Now, a year's rainfall means around 2004, 2005 millimeters. So we're talking about a fifth, which means yeah. So it's actually happened before. I look at the history of the extreme rainstorm events and trying to correlate. I think you guys has already established a relationship between the landslide density and the normalized rainfall in 24 hours. And this is the magic cutoff, 20%. Actually, I look at all the past records and the GEO reports and end up, of course, it's not very certain for some of the cases, but I managed to, got quite good correlation with these fittings. And I found that 2008, actually around this point, is not yet the worst. In fact, in Hong Kong, we had two events, 1926 and 1889, to be even higher. And actually, the 24-hour rainfall or the one-day rainfall was even higher than 2008. So I have been trying to say that 2008 is not the worst scenario. It's not the worst scenario. We have to plan for even worse scenario because it has happened before, not to mention the effect of climate change. So, and of course, sea level will continue to rise no matter whether we manage to mitigate better, because the melting effect of the global warming has already been committed, and CO2 will remain in the atmosphere for hundreds of years. And so even if we stop emission today, the ice will continue to melt, of course, at different rates. But you can see that the different scenarios will still put the sea level rise to above half a meter, no matter what is above half a meter. And the higher sea level will mean that the storm surge risk will increase. And so we have computed the return period for the different extreme sea level events. And we found that in the past, 1 in 50 years event will become actually an annual event by the end of the century. And it is very easy to imagine because the high tide, the maximum level of the high tide now is already 2.5, around 2.5, 2.6 meter above chart datum. And if you add 1 meter to the 2.5, 2.6, it's already 3.5, which is Hato, which is already a storm surge event, just during the normal high tide, low tide, high tide cycles. So if we look at the history, in fact, of course, Hato came this year. And so if you remember, in 2008, we have a Huckabee, which caused the flooding in Taiwan. And at that time, we calculated the return period to be 1 in 50 years. But now, with Hato, we already have to adjust the return period to 30 years. So, Hato, 3.57 meters of sea level. Typhoon Wanda in 1962, which had severe flooding in Shatin, killing more than 100 people, was 3.96 meter. And actually, in 1937, we have an even higher level of 4.05 meter. And that typhoon actually killed more than 10,000 people in Hong Kong. And Tai Po village was devastated by storm surge. And these are the records. And in fact, before 1937, we still have historical typhoons which brought very severe storm surge. If you look at the Cool Mad Stuff video that we just broadcast yesterday, you will get more information. And for Hato in August this year, you can see that the tide level was higher than Huckabee in 2008. In the total harbor, we have about 4 meters, and actually Chim Pei Choi even 4.56 meters. And so there was actually some unexpected flooding in the Yuen Long areas. And in Macau, it was 5.26 meters. And actually, I've checked that actually the highest tide level did not coincide with the storm surge perfectly. So if they coincide, then it could be 5.6. And now, Typhoon Wanda. Actually, Typhoon Wanda and Typhoon Hato actually both similar intensity, but Wanda was closer. It actually passed over Cheung Chau. So we are a little bit lucky because it didn't come too close. But you see, it's very close to Macau. And we try to calculate in the case of the Typhoon Hato, if we move just 20 kilometers closer to Hong Kong, what will happen? And this is the result. In Victoria Harbour, the sea level will rise to beyond 4 meters, so which means it is exceed Typhoon Wanda of 1962. And for the Tai Po Cow, it would even be 5.2 meters, so 1 more meters beyond this time. So again, also exceed Typhoon Wanda. Now, what happened if it takes on the track of Typhoon Wanda? Then the sea level at Tai Po Cow even higher, 5.5 meters, higher than Macau. So it really depends on how low you are in the low-lying area, right? Yeah, this is respect to the chart datum. So, and actually we have checked, we have tried to get some first-hand information from Macau. So this is 2 months ago we went to Macau to interview some of the Gai Fong and take some videos. And the sea level was there, 2 meters. So this is not just a normal flooding. It could kill you. And in fact, there are some areas that the highest water level was 2.5 meters above the ground. So check the HKO video, just broadcast yesterday. Duncan has already seen it. So if Heto came closer by 20 kilometers, it's not just the storm surge, but also the high winds. Actually, this time, in the harbor, in the urban areas, we didn't experience the hurricane force wind. We only had storm force wind. So what happened if hurricane force wind came? We already see some problems with the glass curtains. In Central, in Wan Chai, yeah, I have counted the number of floors having broken glass windows, actually more than 10 levels. So it's only storm force wind. So this is I think, a summary of what we need to be prepared. And I also mentioned here with a question mark whether or not the flooding could infringe the MTR, some of the low-lying stations. So I think you all know this. We need to mitigate against climate change. We need to do better in reducing the carbon footprints and greenhouse gas emission. But at the same time, we need to adapt to climate change. And the adaptation, I think, is surely the work of the engineers. And so, and for resilience, I think it's not just the infrastructure. We have done a lot on the infrastructures, but I think the mindset of the people, whether or not their behavior will change, whether or not they will still go out to chase the wind when we have the signals. So this I think a lot of more work on education, more work on outreaching to let people have the awareness, increase their understanding. This is really a big job ahead. Of course, we look forward to working together with all the stakeholders, especially the engineering community. But here I also like to mention 3 challenges for us. In fact, one of the challenges I think is all around us is the skeptics, climate skeptics. You can even see some articles about the benefits of carbon dioxide. And this is on South China Morning Post. And you can see these kind of articles now and then. So we have spent a lot of effort to rebut such wrong information. But still they are around us. They are on the media. So this is, I think, we all have to work together to promote the understanding. Another thing, of course, it's not for us. The melting iceberg it's not for us. So it's somewhere else. But as you can feel already, the effect of storm surge. So actually, it's not something not for us. It is actually very relevant to Hong Kong. And again, not for us. Or maybe Philippines is only a third world country. So, but you can see that it happened in New York, yeah, it happened in Texas, Florida. So why it couldn't happen in Hong Kong? And of course, this is a more difficult subject: how we could change the mindset and behavior of people, the pattern of spending. Consumerism. This is actually a very interesting video on YouTube. You can also look at it, wake-up call. It's actually talking about the use of computers, mobile phones, and so on and so forth. And so how could we stop or reverse this kind of spending in order to, reduce our carbon footprint? I'm not a die-hard environmentalist. I agree that we need to have a sustainable development. We need to spend whatever that is necessary, but we shouldn't waste, and that is, I think, a very, very important thing to be focused on. But I think, as Al Gore has used to coin it as inconvenience truth, a lot of things I think is just for convenience. But how can we change the behavior of people? And I think the most important thing is here. It's not the technologies, it's the mindset. So I think this is time for question and answers. Thank you for your attention.
Okay, thank you, Mr. Shen, for his inspiring speech. So please remain on stage. We will now proceed to the Q&A section. And if you have any question, please raise your hand and our helpers will pass you the mic. So please there, gentleman over there.
Thank you, Mr. Shen, for a very informative lecture there. You talk also about the rising sea level trends and the rising temperature trends. But what are the trends on future changes in wind patterns and wind intensities, particularly in the Asia region? Are there any forecasts for that? Thank you.
This is a not so easy question to answer. We have some studies on the trends of typhoons in the region. I think in recent years you will have noticed that there is a tendency for typhoons to recurve towards Taiwan and Korea and Japan. And therefore there are less typhoons coming to our region, to the South China coast. In fact, this pattern is also observed in the Philippines. In the past, they expect more typhoons to cross Luzon. Therefore, they build more rigid houses in Luzon. But then came Haiyan to the south of Philippines, and therefore they have not prepared. But we have not yet fully understand whether this is only a oscillation, a cycle, or it is actually an effect of climate change, and so permanently more typhoons will recurve to the north. We don't know. There are also some studies suggesting that the number of hurricanes will increase for the Atlantic, but the same conclusion cannot be reached for the Pacific. So we cannot say that there will be more typhoons in our area. In fact, some projections actually end up in slightly less number of typhoons in our region. But this is not I think, not accurate enough, because in the past, the determination of the intensity of typhoons have not been based on very accurate data. And so it's not easy to get a reliable trend. So, but one thing that we are quite sure is that the typhoons will be more intense. And also, so therefore, you will expect more higher winds from a direct hit of a typhoon. And you will also get heavier rain after landfall of the typhoon. So these two factors, I think, are much better understood. But I would think that for us, the most concern is the sea level rise and the storm surge effect.
Thank you, Mr. Shen. So, please.
Thank you, Mr. Shen, for the very insightful and informative presentation. Now, you did mention about counting the number of broken glass panels at different levels. Can you elaborate a bit on how it is related to the wind characteristics?
Well, I am no wind engineer, so I can't say for sure what. Oops, could I go back to the PowerPoint? Yeah. So, I think what I mean was that even the wind observed in the harbor was only storm force wind, force 10. We already see broken glass panes on some of the high-rise buildings in Central in Wan Chai. And so what will happen when we have a direct hit of hurricane force wind over the urban areas? So that was my question.
The broken pane could be due to the wind suction or wind pressure, but it could also be due to foreign objects breaking it.
Yeah.
I just have to put some media actually asked me that question, how to assess whether it's due to the foreign objects hitting it or whether it is the wind suction.
Okay. Well, this is also a question that we asked the applicants of the scientific officers. If you remember when we have Typhoon York, many glass windows were sucked from the revenue tower. And so it is not, I think most likely it's not due to fallen objects. It's due to the Bernoulli effect, just like a lifting wing. So you have very, very high winds passing by, and so causing a difference in the pressure. And therefore the glass being pulled out instead of pushed into the building. So we observed that this could be the reason. And so that will depends on the wind strength. That will depend on the wind strength.
Thank you, Director Sun. Thank you very much for heightening our awareness of storm surge. It's actually relevant to Hong Kong, and there is a risk in Hong Kong indeed. So in cities and countries with earthquakes, I mean, the government will educate the people how to avoid and find for a place of safety during the earthquake. I'm sure that the GEO has been publicizing the slope safety and get away from the slopes, and they're doing a good job for GEO. But would it be relevant for Hong Kong Observatory and the government to start publicizing this storm surge risk in low-lying areas and start identifying some black spots in the entire region and telling people exactly what to do when they're actually facing a possible storm surge? Yes, instead of just letting the engineers and other small group of people know, let the entire Hong Kong people know. How about that, Director?
So in fact, we are trying very hard to do this. You know, the video that I mentioned is on our website. It's on the iPhone app. So we are doing this especially for after the Typhoon Hato. We have a special episode of the videos to increase the awareness of the public, especially after Hato. I think the public are now get more concerned about storm surge, and they actually can see what happened in Macau. And so this is exactly what we are trying to do. But of course, it's not just HKO that should be doing this. So we are trying to seek help from other relevant government departments, especially those responsible for the contingency planning for natural disasters. And we will try to also enhance the contingency procedures. In fact, there are already a procedure to evacuate people from Taiwan because based on the experience of Hekubit in 2008. There are also 5 other low-lying areas which are, as you said, black spots, hot spots of flooding due to storm surge. And we have very good coordination with the Drainage Service Department. So even before the typhoon came, the DSD will go out and already provide the sandbags to start the preparation to prevent the flooding. But of course, for events like Hato, not enough, of course. So I understand that the relevant departments are now already trying to step up the arrangements. Maybe we will extend the number of hotspots, flooding, low-lying areas that we have need to plan ahead, or even we increase the instrumentation for measuring the tide data for those areas. As I mentioned, Yuen Long, we may need to do something more.
May I offer my humble opinion? I mean, television broadcasting
Yeah.
to educate the public and making them aware of this situation may be more effective than the iPhone app or smartphone app.
I cannot.
Just a thought, that's all.
I cannot fully agree with you, as we know that the television viewers are on the decline, and the younger generation is now using the iPhone all the time. So in fact, we will actually launch a Facebook page for the HKO early next year, trying to reach out more. But of course, the use of API is still a convention that we will also use. Yeah.
Are there questions over there? Please.
Thank you, Mr. Sun, for the informative speech. Actually, I live in Yuen Long. I need to do something, and I look forward to the government to do more. You mentioned you went to Macau for an investigation. Apart from the difference in search, they got a higher search during the Hato. What other areas that you think? What are the reasons they have more damage than Hong Kong? On the other hand, what did we do better than Macau for that?
I will try to control myself and not to comment on what Macau has done. So, but for the facts, yeah, that's why we try to go to Macau and learn from the facts. So we try to present the facts to you, to Hong Kong people. So apart from storm surge, actually most of the I think the deaths were due to the storm surge. But also, I think at least one person was, I think, dragged out from the building after the window yield, so and killed him. And so, of course, the wind was higher. Actually, Macau directly experienced hurricane force wind, but Hong Kong, we only had hurricane force wind over the southern part of Hong Kong. So urban areas actually has escaped the full force of the typhoon winds this time. So, and of course, I have been saying that we have been lucky because the typhoon was a little bit further away, and it also, we of course have the number 8 signal already enforced before people get to work, and so that's of course really, really important. But what I have learned from this case is that we are still not enough in forecasting the intensity change of typhoons. In fact, this is a really challenging topic. As you know, in some cases, when we have forecast a typhoon to come, then it actually dissipates. You remember a few cases, yeah. And this time, Hato is opposite. When it approached the coast, actually it intensified very rapidly. And I don't know why this year, several typhoons underwent a rapid intensification over the northern part of South China Sea, even close distance to the shore. This is unusual. And the rapid intensification also happened in the Atlantic. If you look at Irma, Maria, they all underwent the rapid intensification, probably due to the very warm or unusually warm sea surface. So this is an area I think we also need to pay a lot of attention, because if it's just intensify at our doorsteps, then the warning may not be fast enough. So that I think both Hong Kong and Macau needs to do better. Yeah.
Are there any questions?
Yes, Mr. Sun, so you mentioned about urbanization on the effect of giving a higher temperature in Hong Kong, particularly in the urban area.
Yep.
So have you studied about the effect of this urbanization on the air ventilation, particularly the land-sea beach situation in Hong Kong? Will
Yep.
there be make it more serious due to the urbanization?
Yeah. In fact, as one of my partner is Zhou Zhong here, we have started a collaboration on the smart city, trying to install microclimate stations around urban areas with this in mind. And in fact, we have already done some work in advance, even in advance of this project. We install a large number of so-called iButton, very small sensors of temperatures around Tsim Sha Tsui this year. And we collected the data and analyzed the data and found that, in fact, it has the ventilation, the wind, even the wind direction can make a big difference in the temperature distribution over this small area of Tsim Sha Tsui. For example, we found that the urban heat island, the heat source, is actually just south of observatory, maybe around K11. And so the hottest spot was there. But then if you have easterly wind, then the Tsim Sha Tsui East will be cooler, relatively cooler, because of the sea breeze effect. But if we have the westerly wind, then the opposite will happen. The Tsim Sha Tsui East will be hotter, but the cooler wind from the sea will actually reach the HKO, and so our temperature will become a little bit lower. So you can see only just a small area of Tsim Sha Tsui with very complicated buildings and terrain and some parks and so on, and coastal environment, you can have a very complicated distribution of the temperature. So, well, we definitely will do more studies and try to build more smart city IoTs to do this.
I think there are questions over there.
Mr. Chen, thank you for your information. I just searched the Hong Kong Observatory information, and I found that the Hong Kong sea level in the Victoria Harbour hasn't risen since 1999. Please correct me if I'm wrong, because it seems that it is a little bit contradictory to what you have just mentioned.
I have already shown the chart here. This is the chart. You cannot just determine the change just based on a few years of data. So you may be right if you just look at this 10 years or so, but if you can look at the long-term change, then you can see the rise. In fact, this increase of sea level actually is not just Hong Kong. You can also look at Macau, look at the surrounding sea areas. So if you look at the global change, you can also see the rise. So in fact, if you look at the temperature, you can also see this, what the skeptics has used to argue against climate change. One can also say, oh, this 10 years, you have no increase. So climate change is wrong, there is no global warming. But you cannot just look at this small duration. Climate is, normally we'll talk about at least 30 years or even longer in order to compare with the past. Then you have a definite trend. But if you just look at the small duration, then you can't really see the change. So a lot of people, skeptics, try to make use of this so-called hiatus to say that the global warming has stopped. But actually it hasn't stopped. You can see that it's jump up after a while. So really, you have to look a longer period.
Are there any questions over there? Oh, thank you.
Mr. Trump, your distinguished lecture is short but comprehensive, and the answer is already there, at least partly to my intended question. My question is, the climate change, has it substantially changed the work, or will it substantially change the work of the observatory? And the way Hong Kong structure your work or the engineering work, do you think it's enough to guide your work, or some infrastructure should be placed to lead the cooperating efforts of all parties? Or, since you are a high government official, it's wise and even obligatory for you to avoid commenting on Macau. But the recent rainstorm in Macau, it seems to suggest that Macau is not so up to date, that the whole community is not up to date to face the challenges. Hong Kong, we may be lucky. Do you think we are well prepared to face these challenges in future?
Yeah, of course, climate change is a challenge for everybody. It's not just for Hong Kong Observatory, but this definitely requires more effort on the part of HKO to do more research on the effect of climate change on Hong Kong and also on the neighboring areas, because we can't just look at Hong Kong. If you look at the water supply, where our water comes from, we need to also look at how the rainfall will be affected by climate change, not just in Hong Kong, but also in Guangdong. So really, as you said, more efforts will be required. And hopefully we will get more resources to do this. And I'm very positive. And of course, more extreme weather will also be a concern. And we have already seen this around us. So this also poses a challenge for HKO, because in the past, we only maybe expecting extreme weather events only in the summer. But now, around the year, we have something new. Sometimes we have extreme cold event, unexpected. Sometimes we even have a sandstorm. I think you remember several years ago, we have some sand dust coming from Mongolia. So all these are extreme events, which is actually, by definition, very difficult to forecast. So this is another challenge. For Macau, I think, yeah, we definitely need to step up the cooperation. And I think nowadays with the highly connected Pearl River Delta, even an area outside Hong Kong has a trouble in climate extremes, we will be affected. And so I'm also trying very hard to look at our history, what could happen as a worst case. And I discovered that actually even before the 1874 typhoon, we had an 1862 typhoon, which brought a serious storm surge all the way to Guangzhou, killing more than 80,000 people, according to the historical record. I haven't yet got the data to really do a scientific study. But this kind of disaster could happen. And so given the highly connected nature of our Taiwan area, so we really need to think about this perspective as well.
I think time is limited, so we welcome the last question.
Director Shun, thank you for your talk and your sharing. Well, it's a reminder to all engineers. About those events with little probability they do occur quite often, quite frequently these days, and the return period reduces a lot, and the intensity has been increasing. Quite different from what we expected before. Normal, we all expect normal, but nowadays, you told us that more extreme cases will be coming. I would suggest the Hong Kong IE should set up, research committee maybe to look at the impact, the effect of the extreme weather, and also we should look at how we will modify our core practice, our design standard that we need to cater for such adverse effects. And this is my recommendation, my suggestion to Hong Kong IE. And well, you said at the start that you have got too many bad news. So I'm asking you, are there any good news? And is there, the worst is yet to come? Well, this is my conclusion. Thank you. I'm looking for your answer.
Well, I think your first recommendation is also what we hoped that we could work more closer together, especially for preparing for adaptation for future extreme weather. We have to look at in the holistic way, because disaster could come in a multiple hazard manner, which means storm surge can come, heavy rain, and flooding, landslides, and so we have to be prepared for multiple hazard scenario. So that needs to be quantified. But we cannot just look at these different angles separately. We have to look at them together. How the city could respond effectively to such a challenge. But on the other hand, we cannot just simplify the scenario. For example, as I mentioned, the water level can be up to 5 meters. But are we saying that the whole Hong Kong will be under 5 meters water? No. It's because the wind and the shoreline and so on will means that only certain low-lying areas will be affected. So different scenarios, different tracks of the storm will lead to different scenarios. And so I think we need to work together to define the scenarios for us to be prepared. So this is your first question. The second question, can you be more specific? Good news. I think bad news will be coming because every year we will see a record breaking all the time. But I think good news will be mainly come from not the Mother Earth. The Mother Earth will give you bad news, but the people, the communities could give you good news. For example, more and more cities are adopting a greener lifestyle, even zero carbon buildings, or even negative carbon buildings, new technologies, and I think those, and also the use of greener and greener technologies, and I think those are the good news. We hope that we will get more. Thank you.
Okay, thank you, Mr. Shen, and all of your attendance. And this marked the end of the lecture today, and I hope you all enjoyed the lecture. Please reminded that to fill in the attendance certificate and let our staff to stand at the reception counter. Thank you for attending again, and see you.